All right, let's take some time to look at the AP Statistics Free Response questions from 2016. Very similar to the other ones we've been doing. It starts with several formula pages that you can reference. And then we get, yeah, this one's especially good. Then we get to the first question that is going to be describing a distribution. So Robin works as a server in a small restaurant where she can earn a tip from each worker that she serves. The histogram below shows the distribution of her 60 tip amounts on the day of work. So remember, before you do anything, when you're describing a distribution, you should be thinking in terms of the acronym SUCS. And that means shape, anything unusual like an outlier or a gap. Center is the mean or the median, and how spread out the data is. So for A, say something along the lines of the distribution of tips is skewed right with a median. And I say median because it's skewed. If it was symmetric, you should be referring to the mean. But the median is between $2.50 and $5. You could also say maybe $3 or $4. But we said that there's 60 tips, so that means the first 25 are here, the next 22 are here. If there's 60 tips, 30 would be the median. 30 is somewhere in this bin. And if we know that's 0 to 5, right here would be $2.50. So the distribution of tips is skewed right with a median. That's between $2.50 and $5. There appears to be a high outlier between $20 and $22.50. If they gave you information for the quartiles, or you can find the quartiles, if you have a skewed distribution and a median, you should probably be reporting the IQR. But in this case, it might also just be appropriate to say, most of those tips are between $0 and $5. Between $0 and $5. Also, if you just gave the range, you could say that all tips are between 0 and $22.50. All right, so that would be A right there. One of the tips was $8. If the $8 tip had been 18 instead, what effect would that have? So you need to remember that the mean is sensitive to outliers or extreme values. So that means the mean would increase because it's going to bring it up. The median, however, would not. Since that's typing all the way down there. So since $8 is above the median to start with, remember the median had to be between $2.50 and $5. But so since $8 was above the median to start with, it's not going to actually change what that median value is. So with 18, the median wouldn't change at all. Okay, great. Number 2, go ahead. I'm not going to bother taking 2-3 minutes to read this. I want you to pause this and read it. And I'm going to start up again in like 5 seconds. 4, 3, 2, 1. All right, so there's different ads shown to different kids and what cereal they ate, Cocoa Zooties or Apple Zooties. First, I'm going to mark up some totals. I'm going to zoom in a little bit too. So let's do some totals right here. I believe once I totaled all of that was 56. This was 19. 25, 25, 25. No, I probably should pause and say, you read it. The question's asking, did the data provide convincing statistical evidence of an association? You should really be thinking independence. And once you look at this data is in counts. It's not percentages. It's not means. It's counts. So you should really be thinking in your head that this is a chi-squared test. So I'm going to start A down here. And let's actually write a little bit about this before we get too far. So the data is in counts. We expect more than 5 in each cell. And this is less than 10% of all kids who eat cereal. And that means we should be proceeding a test, with a chi-squared test for homogeneity. Is that it? E. Okay, cool. So now that we do that, we'll need a null. Hypothesis is that there is no association between the commercial shown and the cereal kid chooses. Alternately, there is an association between the commercial shown and the cereal chosen. All right, so now looking up here, we have to find some expected counts. So you're totaling everything up. Oh, there it goes. Here, let's see here. Can I zoom in? Great. All right, so since these are all even split, 25, 25, 25, total 75. That means this 56 should be distributed up evenly. So 56 divided by 3, and that would be what you got here, or 1/3 times 56. And then it would be evenly divided. So $18, not dollars, 1875, 1875, 1875. So this is how many we expected to choose cocoa. Then 19 divided by the 3, 6 1/3, 6 1/3, 6 1/3. So the chi-squared statistic is always observed minus expected squared over observed, or otherwise I would really just say use the calculator for an observed minus observed, not minus, observed and expected list. So it'll spit out a chi-squared value and it'll spit out a p-value. The chi-squared value should have been about 10/291. P-value was really low. So we should say, with a p-value that low, we should be rejecting our null hypothesis, but we should also state an alpha level. So something like, we reject null hypothesis with p-value 0.006 and alpha, let's just make it 0.5 like usual. It seems there is strong evidence that suggests. Nope. All right, I'm back with just a couple seconds left here, so I typed all of this out. We reject the null hypothesis with a p-value of 0.006 and alpha 0.5. It appears there is an association. Part B right there, it looks like it's only affected with the Apple app.